It seems whenever you try to tell somebody that if you have repeating nines that go on forever and ever and ever, so 0.99999 forever, that when you say that that's equal to 1, they think you're crazy, right? They think there's no way. And their argument basically is, well, if I'm getting closer and closer to 1, I never actually get there. Well, the idea really here, and I'm going to show it in a couple different ways, is that you're not actually getting closer to 1. You're actually already there. And this is just another way of writing 1. So probably the most basic way of looking at it in any algebra in a book would say, okay, well, let's say that x is that number, is 0.999 going on forever. Then if I multiply x by 10, if I say, okay, 10x, right, that would be 9.9999. I just basically moved the decimal over there. Alright, that's good, fair enough, and nobody probably argue with that. So then if I subtract these two, if I have 10x, right, this guy, minus the one up there, minus that 1x, well, it would be this guy right here. These two guys cancel each other out, right? And you're just left with 9. In other words, you have 9x equals 9. Well, x equals 9 over 9, and hopefully you believe that is 1. And if x is 1, and x is also 0.99999, then 1 is 0.9. And that's one way to look at it. Another way to look at it, and it's probably a little bit nicer, I like this way a little bit better, is, well, okay, nobody seems to argue that 1/3 is 0.3333. You put that into your calculator, that's what you'll come out with. And likewise, nobody really argues that 2/3 is 0.66666 going on forever. And again, nobody really ever argues that 1/3 plus 2/3 is 3/3, right? Well, if I add these two guys, I'm going to get 6 plus 3 is 9, 6 plus 3 is 9, 6 plus 3 is 9, 6 plus 3 is 9. I'm going to get repeating nines forever, which is implying that 3/3 is equal to repeating nines. And we both know that that's just 1. Well, 3/3 is anyway. Now, still not convinced? Well, let's take another repeating decimal. Let's say I have 1/7. And you can do this and try this out on your calculator. Whoops. And you'll find out 1/7 is 0.142857, and that goes on forever. 1/42857. Okay, great. So then, well, what's 6/7? So I'm going to do that on my calculator. 6 divided by 7, and I get, and I'm not, planning this out, but I get 85714285742. Okay, well, 7 and 2 make 9, 4 and 5 make 9, 1 and 8 make 9, 7 and 2 make 9. All these pairs, again, make 9s. Get repeating 9s, right? And 6/7 plus 1/7 is 7/7, which is still equal to 1. Okay, great. Let's try another one. Let's say I have 1/13. What's that? Alright, my calculator says that 1/13 is 0.07692306769. What's 12/13? 12 divided by 13 is, my calculator says it's I'll write it right under here. I'll write it right up there. It's 0.92307692330. And again, if you add these guys up, you get nothing but 9s the whole way. So that means that 13/13 equals 0.9 repeating, which should just equal 1. Show in this video to find it is, well, if here's 0.9, here's 1 on a number line. Well, where is the number that we're looking for, right? Where is that? And if I say, well, what's 1 minus 0.9? That's 0.1. What's 1 minus 0.99? That's 0.01. What's 1 minus 0.999? Well, that's 0.001. So then what is 1 minus 0.9 repeating? Well, that's 0.0000000. It's an infinite number of zeros before I hit a 1. That's strange. So if you don't believe that 0.999 repeating is 1, then